This problem is from geometrical optics and covers the concept of equivalent focal length. Problem says a glass beaker has solid plano-convex base of refractive index 1.6 as shown in the figure. So this is a glass beaker and this base is plano-convex. So this is plane part and this is convex part. And refractive index of the material is given, that is 1.6. The radius of curvature of the convex surface SPU is 9 cm while the planar surface STU acts as a mirror. So the radius of curvature of this surface, that is SPU, this is 9 cm, and this surface, that is STU, acts as a mirror. This beaker is filled with a liquid of a refractive index n up to the level QPR. So liquid is filled, so this is the liquid and this liquid is up to level QPR and refractive index of this liquid is n. If the image of a point object O at a distance h, OT in the figure, is formed onto itself, then which of the following options are correct? So this is the object and image of this object is formed on itself and this distance OT is given, this distance is h. Then we have to choose which of the option is correct. Basically in these options different value of n is given and then you have to find value of h. So if you can write a relationship between n and h, then you can solve this problem. So let us try to solve this problem. Now the main thing of this problem is the image and object coincide. This means a light ray going like this has to come in the same way, so you have to retrace its path. And it can retrace its path only if this light is perpendicular on this surface. This surface is mirror. So if light ray is perpendicular on this surface, it will be reflected back and then it can go to the same position so that the object and image can coincide. Let us see how the refraction will occur on these surfaces. So basically what I have done is I have zoomed this portion. So this portion is zoomed and this is shown here. Now this is a light ray that is coming from O. So this is the light ray that is coming from O and this comes here. Now once it reaches to this surface, it will refract because the medium change. So it will refract. It should have gone like this, but now it will not go like this. It will, corresponding to this normal, it will refract. Now there is another change of surface. At this surface, we will have further refraction. So this is the normal. Now this refraction has to have in such a way so that this light is perpendicular on this mirror and then only it can retrace its path so that object and image can coincide. So this is the main idea. Now this means now this whole thing after finally what is happening, this is becoming perpendicular, or in other words this axis and this line is parallel. So now I can say the effect of this part or this lens and this lens is such that it makes this ray parallel to the axis. This means now I can say this ray is coming from the focus, then only it can be parallel to the axis. So in other words, I have to find equivalent focal length of this length and this length, that is equivalent focal length of system. Now the equivalent focal length basically is related to the power. Power is 1 by f, and if you have two lenses, power simply adds. So equivalent power is power equivalent is equals to P1 plus P2 if you have two lenses. Now power is related to 1 by f, so now I can say 1 by f equivalent is equals to 1 by f1 plus 1 by f2, where f1 and f2 are focal lengths of these lenses. Now how we find focal length? So this is the formula to find focal length. 1 by f is equals to n2 minus n1 times 1 by r1 minus 1 by r2. So this is a lens maker formula. So we can use this formula to find equivalent focal length. First we will find individual focal length and then we can find the equivalent focal length. Now let us consider this length, that is QSUR, that is QSUR. This means this lens, that is liquid lens. This portion is a liquid, so we can say that this is a liquid lens. Now I can apply this formula, that is 1 by f. Let us say this focal length is f1. So 1 by f1 is equals to the medium refractive index is n, and light is basically, we are calculating the focal length with respect to the vacuum. So this n1 is equals to 1. R2 R1, this phase R1 light is coming from this side, so light is coming, so this R1 is infinite because this is a horizontal surface, so radius of curvature of this surface will be infinite, and R2 for this is 9. So from here I can calculate 1 by f1. So 1 by f1 is equals to, so this will be 0 minus 1 by 9 times n minus 1. Now similarly I can write focal length for this length, this lens, that is STUPS, that is base of the glass or base of the beaker. Again I can apply this formula, 1 by f2 is equals to, the material is, this material is 1.6, so refractive index of this material is 1.6, and with respect to air, so this is minus 1, and this is 1 by r1, and this is r1 is this, that is 9, and r2 is again horizontal, so r2 is infinite. So from here I can calculate 1 by f2, and this is 0.6 by 9. Now I can add these two to get the F equivalent. So F equivalent will be this value plus this value. So from equation 1 and equation 2 I can get F equivalent. So now F equivalent is this. You can check the different option. Let us check option A. N is equals to 1.42. So if you put this, F equivalent will be 50 centimeter. So this option, that is H is equals to 50 centimeter, this is a correct option. Now let us say B option, that is this, N is equals to 1.35. If you plug this, F equivalent is 36 centimeter, this means H is equals to 36 centimeter because light is coming from H and H is 36 centimeter. So this option is also correct. Now C option, N is equals to 1.45. In this case, F equivalent is 60 centimeter. So this is incorrect. And the final is option D. In this case, N is 1.48. From here you can see F equivalent is 75 centimeter. So these two options are correct and these two options are incorrect. So I hope you enjoyed this problem. In this case we have added two focal lengths, we have added two powers basically because both lenses are same in nature. They are trying to converge the ray, and that's why power is simply added. You can have a situation in which lenses are opposite. So one is converging the ray, another is diverging the ray. In that case, F equivalent will be not simply added. You have to basically see it can be 1 by F1 minus 1 by F2. So you can see the nature of the lens and then you can write this formula. Or you can also solve the same problem by using the sign convention properly. But it's also good idea to know what is this lens doing. If it is converging, then both power will be added. So that's what we have used in this problem. If you follow the sign convention, you will also get the same answer. So I hope you like these videos, and if you like my videos, please share with your friends, like on my channel and subscribe to my channel. I will see you in the next video. Thank you.